Hello guys, and welcome to today's video. Right guys, this video we're going to be looking at the arc length of a circle. Okay, so it's going to be aimed at GCSE Foundation and higher. Okay, so we're going to be looking at grade 5/6 work actually. Okay, if you're new guys, obviously welcome. My name's Abdallah W, and I'm a private maths tutor, and I'm a qualified teacher as well for secondary maths. Okay, don't forget obviously to drop the video a like and subscribe if you're new. Okay, and enable the notification bell. Okay, but on with today's lesson. Right, guys. So we're looking at the arc length. Okay, so the arc length here means a section of the circle. So if you look on this photo here, this is what I call an arc. Okay, so it's the circular bit. So it's a section of a circle. So it's just a part of a circle, section of a circle. And we're going to look at 4 examples for today's lesson. Okay, on how to calculate the arc length of a circle. Okay, so arc length here is calculated actually. So it's going to be the angle divided by 360 times 2 pi r. Okay, or pi over theta over 360 times pi d, where theta is just the angle. Okay, now if you remember in my previous video actually, I mentioned about obviously like angles around a point add up to 360. This is why, yeah, obviously this video and the next video where we look at areas of sectors. Okay, we'll be looking at, yeah, obviously obviously like parts of a circle. So like arc length and the sector looks at like a section of a circle, yeah, a part of a circle. Okay, so if you just look here, guys, so this is what I call a sector here. So sector is this region here, and the arc is just the end bit here. Okay, so that's like a key difference, guys. Okay, although they could be interpreted as like similar words actually, but obviously for our purposes, when we look at arcs here, we are thinking of like circumference of circles, and when we look at sectors, we are thinking of like, yeah, obviously areas of circles, yeah, areas of parts of circles. Okay, so circumference of a circle is 2 pi r or pi d. Okay, so we're looking at the circumference. Okay, so what we've got here, guys, is I've made one up actually. Okay, so I've got like a semicircle here. Obviously, semicircle means that I'm gonna have 180 degrees there. Okay, and then I'm told that diameter is 10 centimeters, and I want to work out, yeah, this bit here. So obviously ignore the 5 pi, okay, because obviously that would obviously be my answer actually, but I will show you how I got 5 pi. Okay, so firstly, okay, I knew that diameter was 10 centimeters, radius was equal to 5. Okay, so I subbed that into the formula here. So it's 180 divided by 360 times 2 times pi times 5. Okay, that's going to give me a half. Okay, 180, yeah, it's just half a circle, so it's going to be half times 10 pi, which gives me 5 pi centimeters. Okay, so this part here is equal to 5 pi. Okay, so that will be my answer. Now, the reason why I've put this on actually, before I obviously start my examples, guys, is I've seen in the past year, in many like exam papers actually, the question would say, yeah, find the perimeter of this shape. Now, if I put the answer as 5 pi here, that would actually not be correct, because the perimeter is the total distance. So being careful here in your exams, guys. If it asks for the arc length, it's just that section there. And if it's asking you for the total perimeter, then the total perimeter would be 5 pi plus 10 centimeters, which will obviously be your exact answer, which will give you some numerical answer if you put it into your calculators, guys. Okay, so that's just like a little key point here that I thought I'd mention, because it's quite important actually, obviously, when we cover this. Right, guys, okay, so 4 examples that we'll be looking at for today's lesson. Right, example one actually, arc length. Okay, so we are given this, guys, find the arc length. Okay, so that's a quarter of a circle. Okay, so yeah, so it will be 90 degrees. I'm given the radius, so it's 90 over 360 times 2 times pi times 4, which gives us an answer of 2 pi centimeters, which is the exact answer, and then the numerical answer is 6.28 centimeters to 2 decimal places. So that's how I work out that one, guys. Right, example 2. Okay, so we are given 84. Okay, so I should have actually been clear, guys. Actually, 84 is the radius. Actually, I don't know why I put it there. So 84 should, yeah, it should just be the radius actually for that one actually. Okay, so I'm treating 84 as a radius. Right, so find the arc length. 180 divided by 360 times 2 times pi times 84, which gives me 84 pi centimeters, which is my exact answer, which is 263.89 centimeters, yeah, to 2 decimal places, okay? Right, example 3, guys. Okay, so we've got a sector of a circle. Okay, so we can see here that would be a quarter, okay? So we know that has to be 90. Angles around a point actually add up to 360. So the remaining angle here will be 270. So find the arc length. So it's 270 over 360 times 2 times pi times 3. So that's a 3 there. Apologies if it's not clear. Okay, which is 9 over 2 pi, which is 14.14 centimeters. Okay, so that's how I'll work out that one, guys. Right, guys, moving on to the last one, actually. Right, last one, obviously, is slightly more tricky, actually. Right, so we are given here, okay, the arc length, okay? So we are given the arc length to be equal to 10, okay? We want, oh, sorry, yeah, sorry, the question should be find the radius, actually, and not arc length. So the question is actually find the radius, so ignore it says arc length. So find the radius. So we need to work out, yeah, what the radius is actually, and that's going to involve actually rearranging, okay, our formula that we had up here. Okay, so this time we are given the arc length and we are asked to work out the radius. Okay, so let me just fix that up there. Okay. Okay, apologies for that, guys. Okay, so we are asked to work out the radius. Okay, so that's going to involve, yeah, like rearranging, like I said. Okay, so we know the angle, okay, so it's 130. We know the arc length, so all of this here is equal to 10. We know the angle, okay, we've got to rearrange to make R the subject. So what I've put here is 130 divided by 360 times 2 times pi times R must equal to 10. Okay, and then to get on its own, actually, I've done a bit like a big jump, actually. So then I've said 13 over 18 pi R equals 10. R is equal to 10 divided by 13 over 18 pi, which gives me an answer of 4.41. Okay, so I was just checking out my calculator there. So the answer is going to be 4.41 centimeters to 2 decimal places. So that is how I would work out that one, guys. Okay, so it is rearranging that formula, actually. So if you're not sure about that, actually, I've made a video like a while ago, actually, on like rearranging formulas, actually. So you're welcome to check that out, actually. I think I filmed it about 3 or 4 months ago, actually. So yeah, it was a while back, actually. So rearrange, actually. So the idea is I would try and make R the subject, and I would do that by so here, actually, so I've simplified here, actually. So it's pi r theta over 180, because what I've done is I've cancelled the 2 pi on the top, actually, okay? So to get r on its own, actually, I would have to divide by 180 over pi theta, actually, not pi r. So if you're interested, that is the formula that I used, actually. So I did 180 divided by pi theta, actually, yeah, obviously, essentially, tell me work out what the arc length was. So yeah. If that makes sense, like, if it doesn't, yeah, then please just like ignore that, actually, and just stick to like rearranging like this one here. Okay. Right, guys, thank you for watching. Yeah, yeah, please do obviously subscribe if you're new. Yeah, drop the video a like, enable notifications, okay, and then check out obviously Corbett Maths, Primo's Kitten, and Maths Chelsea, actually. So Maths Chelsea is like a recent like YouTube account that's actually recently opened, so check them out, guys. Okay, yeah, and this was like a GCSE like level video, actually, aimed at grade 5 and 6, yeah, for Higher Foundation. Okay, thank you for watching, guys, and I hope you're all well. Okay, have a nice evening now. Okay, thank you for watching. Bye now.